Hello again, and welcome once more to a video introduction and illustration of IBM's WebSphere Application Server for ZOS Optimized Local Adapters, or WOLA for short. This is the outline for the subjects covered in this 5-part series on WOLA. This is the second of 2 videos in which we'll cover the WOLA APIs used for native programs such as COBOL. The Java programming considerations will be covered in the next section. Now we'll take a closer look at the BBO-A1 Reg API and show you the parameter syntax used by the API. We'll start with a bitmap clip straight from the InfoCenter article we've referenced already. This is the parameter syntax for the BBO-A1 Reg API. All the APIs have a syntax map like this. The first 3 parameters are all input values. They are the cell, node, and server short names. The next 4 parameters are also input values. The register name parameter is what you use to provide a handle for the registration pipe. That handle is used by other APIs to know which registration to talk over. It's also used by the Java program to know which registration to talk over. MinCon and MaxCon define the minimum and maximum number of connections within the registration. Taking the default works well in most cases. Register flags is a parameter used to control the security, transaction, and tracing capabilities of the registration pipe. The InfoCenter page spells out precisely how to code this and what should be provided. The last 2 parameters are return values. This is what this API returns after your program invokes the API. The 2 parameters are return code and reason code. Again, the InfoCenter article has a complete write-up of return code and reason code pairs for each API and what non-zero values mean. Just a quick reminder, recall our discussion of the CICS support and the BBOC control transaction that's supplied. The BBOC register command will execute a registration behind the scenes using this API based on the parameters you supply to that BBOC command. The BBOC start server command will do the same. So if you're using the BBOC transaction to register, then you do not need to use the BBO-A1 Reg API in your program. Now we'll take a look at the BBO-A1 Invoke API. This API is used to drive the target EJB in the WAS server. Again, a bitmap from the InfoCenter API reference page, this time showing the BBO-A1 Invoke API. The first parameter we'll look at is an input parameter called register name. You provide to this the registration handle name we mentioned when discussing the BBO-A1 Reg API. Next, we'll focus on request service name, another input parameter. This names the EJB you wish to invoke. The value you provide here is the JNDI name of the deployed EJB. This brings up an interesting note. The EJB in WAS does not know it's being called by a batch program over WOLA. It thinks it's being invoked by another EJB using IIOP. And in truth, the final call to the EJB really is IIOP. It's just that the call started out using BBO-A1 Invoke from outside of WAS. The next 2 input parameters are the request data you wish to send in and the length of that data. When using the API, you don't actually pass in a long string of request data. You pass in a memory pointer to the start of the request data, and you pass in the length of the request message. WOLA then goes to that memory location and grabs the specified length and processes it across the WOLA registration. The next 2 input parameters provide the memory location and memory area length for the response data you will get back from the Java program in WAS. Now here we see one of the things we spoke of earlier that makes BBO-A1 Invoke easy to use by imposing an assumption on it. BBO-A1 Invoke assumes you know ahead of time the maximum possible length of the response coming back from WAS. The advanced APIs make no such assumption. The advanced APIs provide a way to first get the length of the response, then get the message using the length just determined. 2 APIs and additional programming, but with greater control given to you. The final three parameters for this API we'll look at are all return values. The first two are return code and reason code, just like what we saw for the registration API. The Info Center page provides a full listing of explanations behind the possible return code and reason code pairs you might receive. The RV parameter returns the actual length of the message received and copied into the response area defined with the response data length parameter. Let's now see an example of an actual COBOL program that uses the BBO A1 Reg, BBO A1 Invoke, and BBO A1 Unreg APIs. This is straight out of the WP101490 primer tech doc we spoke of earlier. First, we see the working storage definitions for the parameters we'll use on the APIs. The register and unregister APIs have very similar parameters, so those working storage definitions are combined. The invoke API is defined below. The key is how each parameter value's working storage is defined. Some are string parameters, some are integers, and some are pointer values. The Info Center API reference page spells out what each parameter should be defined as, and the primer document gives examples for COBOL. A little further down, we move values into the working storage areas. The first highlight on the chart shows the values for the cell short name, otherwise known as the daemon group name, and the node and server short names. The other highlighted value is the service name, which we explained earlier is the JNDI name of the deployed EJB you wish to invoke. Next, the program invokes the BBO A1 Reg API. Program control for registration does not return until the registration completes or fails. The code shows a follow-up check of the return code. Greater than 0 indicates a problem. Then, some of the parameters for the BBO A1 Reg are set up, and the API itself is invoked. Once again, notice the register name and service name parameters. You must tell WOLA what registration to communicate over and what the name of the target EJB is. That's what these two parameters provide. In this example, there is no looping structure, just a single invocation, then the registration is torn down. The BBO A1 Unreg API is used to do that. That is a very simple example of a COBOL program using WOLA to invoke an EJB and WAS. It served the purpose of reinforcing some key concepts. To register, you must specify the cell, node, and server. Invoking the EJB is done over a named registration. The target EJB is referenced with its JNDI value. Even though this example didn't show it, we illustrated earlier how a single registration may be used for multiple invokes. You do not need to register and unregister for each invoke. Finally, we'll note a very subtle thing that took place. Program control was held from the COBOL program until the Java program returned with a response. That's an example of synchronous processing. It makes things very simple. If the Java program took 5 seconds to respond, then the COBOL program would wait that 5 seconds before doing anything else. The advanced APIs provide asynchronous processing, which returns program control immediately. That allows your native program to perform other processing while the Java program processes the response. But doing so puts some burden on your program to come back at some point and check if a response has been received. It's not difficult, but it is necessary if you use the asynchronous API function. We spoke earlier of how the primitive APIs give you more control. Let's see how that works. BBO A1 Invoke is a basic API. The function it provides is equivalent to the function provided by the corresponding 5 advanced APIs shown. The first gets a connection from the pool of connections in the registration. The connection comes with a connection handle, which is a number used to uniquely refer to the connection. This is important if you have multiple connections at work simultaneously and you need to process the message on a specific connection. BBO A1 SRQ sends the message to the EJB and WAS. As you might imagine, the parameters on this API are related to what we saw on BBO A1 Invoke. BBO-A1RCL is used to get the length of the response from a previously sent request. BBO-A1GET is used to get the returned response. BBO-A1CNR releases the connection and returns it to the connection pool. The send request and response length APIs may work in either synchronous or asynchronous modes. When operating in asynchronous mode, the program control is returned immediately. This allows your program to do other work, such as process requests over other connections. Which brings up another benefit of the primitive APIs. To maximize throughput, particularly if responses back from WAS are a bit slow in coming, you'll want to open up multiple connections and process messages overall simultaneously. There's a fair amount of programming required to keep track of the connection handles and such, but it is possible and it does provide better performance. In addition, there's no reason to return a connection to the pool if you know you're going to be using it again right away. So it's possible with the advanced APIs to reuse the connection over and over again. The benefit is a fraction better performance, and when striving for very high throughput, every little bit helps. The BBO-A1Invoke API gets and releases with each invocation. And finally, the advanced APIs are useful when you can't be certain of the maximum response length ahead of time. Let's turn our attention to the outbound APIs. Here, the native program hosts a service and goes into a listen state until the Java program in WAS sends over its request. The basic outbound APIs consist of the three shown on the chart. BBO-A1SRV is what hosts the service. BBO-A1SRP is what sends the response back to the Java program. And BBO-A1CNR is what releases the connection. These work in synchronous mode. Those three are equivalent in function to that provided by the 6 primitives shown. BBO-A1RCA and BBO-A1RCS hosts a service, with one allowing you to listen for a request on any connection and the other listening on a specific connection. The three APIs in the middle are used for both inbound and outbound. They perform the function shown on the chart. The BBO-A1SRX API is used to send an exception response back to the Java program in WAS. Outbound calls and hosting a service can be more challenging than inbound invokes of the EJB. That's one of the reasons why the CICS and IMS support provided a way to avoid the APIs altogether. Please be aware that the link server task was using the primitive outbound APIs deep inside itself. The link server task provided a simpler framework for using them. And it also provided some of the security and transaction propagation we saw earlier. Let's walk through a summary of the APIs discussed in this section. There are 13 APIs at the present time. There are 4 supported native languages. The InfoCenter reference article for the APIs is the best source of definitive information about the APIs. Which APIs you use is a function of what you are trying to do and how much programming control you require. And depending on what you're doing, you may be able to ignore the APIs altogether by using the shielding mechanisms we spoke of in the CICS and IMS sections.